Hello friends, I welcome you in lecture number 32 on Laplace transform. In lecture number 31, we have discussed this formula for finding the inverse Laplace transform of a function whenever our function is either logarithmic function or inverse trigonometric function like tan inverse, cot inverse, etc. So today also we are going to discuss some examples on that formula. So for that we just recall that formula which we are going to use in this lecture also. So we are familiar with this formula of Laplace transform, that Laplace transform of a function f of t into t is given by minus derivative of Laplace transform of f of t, where capital F of s is nothing but Laplace transform of f of t, and using this formula we obtain the formula for inverse Laplace transform of negative of derivative of capital F with respect to s. This is equal to t into f of t. We know that if Laplace transform of function of t is this function, then inverse Laplace transform of this function is t into f of t. So we are going to use this formula to obtain inverse Laplace transform of this function, and we have discussed one example related to this formula in lecture number 31 also. So first step is we denote given function by capital F of s. Let capital F of s equal to log of 1 by s, and we can rewrite our function capital F of s using the property of logarithmic function. I can rewrite this as log 1 minus log s, and here log is natural log, therefore value of log 1 is 0, and we have minus log of s. Now to use that formula we require derivative of capital F with respect to s. So we differentiate both sides with respect to s. Derivative of log s is minus 1 by s. Now we require negative of df by ds. So we multiply both sides with respect to s, and here we have minus df by ds equal to 1 by s. Now we take inverse Laplace transform on both sides, therefore L inverse of minus df by ds is equal to L inverse of 1 by s, and as we have discussed, this is going to be t into f of t, because Laplace transform of t into f of t is minus df by ds. Therefore inverse Laplace transform of minus df by ds equal to t into f of t, and inverse Laplace transform of 1 by s is 1. Therefore f of t equal to 1 by t, and f of t is nothing but inverse Laplace transform of capital F of s. So we have obtained inverse Laplace transform of given function, which we have denoted by capital F of s, and now we substitute capital F of s equal to log of 1 by s. So this is very easy method. Whenever your function of s contains logarithmic or inverse trigonometric function, then you can find out inverse Laplace transform using this method. We can discuss one more question also. Find the inverse Laplace transform of log of s plus b divided by s plus a. Here a and b are constants. This question was asked in GTU Winter 2010 exam. So here also we will apply the same method. We can start with our function that we denote by capital F of s. Denote given function by capital F of s log of s plus b divided by s plus a. Now we require derivative of this function, but before taking derivative we rewrite our function using the property of logarithm. Log of s plus b divided by s plus a can be written as log of s plus b minus log of s plus a. Next step is take derivative on both sides with respect to s. Here derivative is 1 divided by s plus b and derivative of log of s plus a is 1 divided by s plus a. Now we multiply both sides by negative 1, so this we can rewrite as 1 divided by s plus a minus 1 divided by s plus b, multiplying this equation both sides by minus 1. Now we take inverse Laplace transform on both sides. L inverse of minus df by ds equal to L inverse of 1 divided by s plus a minus L inverse of 1 divided by s plus b, and this is by formula t times f of t, and L inverse of 1 divided by s plus a is e raised to minus at. L inverse of 1 divided by s plus b is e raised to minus bt, and we are interested in f of t, which is inverse Laplace transform of capital F of s. So we take this t on right hand side and we obtain this function of t, which is required inverse Laplace transform. F of t is nothing but L inverse of f of s. So this is e raised to minus at minus e raised to minus bt divided by t, and finally we replace capital F of s, which was log of s plus b divided by s plus a. Let me check. Okay, it is s plus b divided by s plus a. So we have obtained the inverse Laplace transform of log of s plus b divided by s plus a equal to e raised to minus at minus e raised to minus bt divided by t. So in this way we can answer this type of questions. This question was asked in GTU Winter 2010 exam, and this was also asked in GTU Summer 2011 exam. In both the questions we are just using this formula, negative of inverse Laplace transform of negative of df by ds equal to t times f of t. So for that, first we denote given function by capital F of s, then we find out minus df by ds, and then we take inverse Laplace transform on both sides. So this is all about this session. I hope you like it. Thank you very much.